Dear students, under the lecture series on complex analysis, we are solving problems under analytic functions. Now, here the question is to find the analytic function f of z equal to u plus iv if u plus v is equal to sine 2x divided by cos h2y minus cos 2x. Having this, we have to find the analytic function f of z. That is, we have to find u separately and v separately and substitute in f of z equal to u plus iv. Using the concept that f of z is an analytic function. That is, we will be making use of the CR equations in order to find the value of u and the value of v. So let us first proceed to we shall take the given equation, that is u plus v equal to sine 2x by cos h2y minus cos 2x as equation 1. So having this as equation 1 and differentiating equation 1 partially with respect to x, we get the differentiation of u partially with respect to x is ux plus the differentiation of v partially with respect to x is vx is equal to. Now on the right we have x in numerator as well as in the denominator. So we have to use u by v rule in order to differentiate this. So as per the rule we know that the differentiation of u by v is equal to v square in the denominator, v multiplied with u dash minus u multiplied with v dash. So in this way we have to differentiate the right hand side. So v here is cos h2y minus cos 2x. So the square of v, so cos h2y minus cos 2x, the whole square will be there in the denominator, and in the numerator v, so cos h2y minus cos 2x multiplied with u dash, that is differentiation of sine 2x. So the differentiation of sine 2x is cos 2x, and by using the chain rule this 2x also should be differentiated. So this constant has to be multiplied and differentiation of x is 1. So differentiation of sine 2x will be 2 cos 2x. So 2 cos 2x minus u will come as it is. So this is u. So sine 2x will come as it is multiplied with the differentiation of v. So what is v? So this is v. So cos h2y will be treated as constant since we are differentiating partially with respect to x. So differentiation of a constant will become 0, and then minus we have cos 2x. What is the differentiation of cos 2x? It is sine 2x multiplied by the constant 2. So it will be minus sine 2x. So minus and minus gets multiplied and it becomes plus, and then we have 2 sine 2x. Now we will multiply these terms in the numerator. That is, we will write this 2 in the front. So 2 multiplied with, so this we will write as it is, cos h2y minus cos 2x multiplied with cos 2x minus, this 2 comes in the front, and here we will be having sine squared 2x, because when sine 2x gets multiplied with sine 2x we get sine squared 2x, the whole divided by cos h2y minus cos 2x, the whole square. So we shall mark this as ux plus vx. So we shall mark this as equation 2, because already we have marked this as equation 1, and so this will be equation 2. Now what we will do, we will again differentiate equation 1 partially with respect to y. Like how we did partially with respect to x, we will differentiate equation 1 partially with respect to y now. So when we differentiate partially with respect to y, what do we get? Again, we have to differentiate u plus v, which is equal to sine 2x divided by cos h2y minus cos 2x partially with respect to y now. Now since y is in the denominator, we shall use u by v rule again. So when you differentiate u partially with respect to y, you get uy plus v partially with respect to y, we get vy is equal to, so when we use the u by v rule, In the denominator, we will be having cos h2y minus cos 2x the whole square. And in the numerator, cos h2y minus cos 2x multiplied with the differentiation of the numerator, that is u. So what is the differentiation of sin 2x? It will be 0 because it will be treated as constant. So on differentiation it will become 0 as we are partially differentiating with respect to y. And then minus, now sin 2x will come as it is. We have to differentiate the denominator, that is v. So on differentiation, cos h2y will give us sin h2y because the differentiation of cos h2y is sin h2y, and this constant 2 has to be multiplied, and so we get 2 sin h2y. So irrespective of sin x and cos y, I mean sin x cos x, where on differentiation cos will yield a negative sign. Whereas for hyperbolic function you have to remember that just it is sin h2y and we will not have the negative sign. So remember that. So therefore what will be uy plus vy? It will be equal to, this term becomes 0. And what about this term? Minus this 2 we will write in the front. Then sin 2x multiplied with sin h2y divided by cos h2y minus cos 2x the whole square. And this will be marked as equation 3. So equation 1, equation 2, and this is equation 3. Now next, since f of z equal to u plus iv is given as analytic, u and v will satisfy the CR equations. So we will write that. So I have written that. And what are the CR equations? We know that the first CR equation is u x is equal to vy. And then the second CR equation is uy is equal to minus vx. So now we are going to make use of these equations in equation 2 and equation 3. Now let us make use of this equation first. So uy is equal to minus vx. We can also say that vx is equals to minus uy. So what we are going to do in equation 2, we are going to replace this vx by minus uy. So what will happen? This equation 2 will change as ux minus uy is equal to these values. So let us do that. That is, we are going to replace this vx as minus uy in equation 2. So substituting, so I will write that here. Substituting vx is equal to minus uy in equation 2, we get. So what do we get? This will change as ux minus uy equal to this whole term. So equation 2 changes like this. Ux minus uy is equal to this value. Now at the point z comma 0 we are going to find. So ux of z comma 0 minus uy of z comma 0 is equal to. So wherever we have x, we will be replacing by z. And wherever we have y, we will be replacing by 0. So what will happen? 2 multiplied with cos h0 is 1. So this is 1 because y is 0. So we have to put y as 0 here. And what is cos 0? It is 1. So it is 1 minus cos 2x. So wherever we have x, we have to replace it by z. So cos 2z multiplied with again cos 2z. So cos 2z minus 2 sine squared 2z, because wherever we have x, we have to replace it by z. The whole divided by cos 0 because y is 0. So cos 0 is what? 1 minus cos 2x will be replaced as cos 2z the whole square. Now this will be equal to, we will multiply this 2 and cos z within the bracket. So what will happen? 2 into 1 multiplied with cos 2z is cos 2z. then this minus 2 multiplied with, we have cos 2z here, again this cos 2z. So on multiplication we will get cos squared 2z, then minus 2 sine square 2z, the whole divided by 1 minus cos 2z the whole square. Now further this will be equal to, now 2 cos 2z we will write as it is. We can see that minus 2 is common in these two terms, which can be taken out, and within the bracket we will have cos squared 2z plus sine squared 2z, the whole divided by 1 minus cos 2z the whole square. So that will be further equal to 2 cos 2z minus 2, and what is this? Cos squared theta plus sine squared theta is equal to 1. So that trigonometric formula we will be using here, and so we will have multiplied with 1 divided by 1 minus cos 2z the whole square. Now in the numerator we will take minus 2 in common. So if you take minus 2 in common, we will be having minus cos 2z plus 1. So we can rewrite it as 1 minus cos 2z, so that we get the same. The whole divided by 1 minus cos 2z the whole square. So we can cancel these two terms. So one of the power gets cancelled here, and finally we will be left out with minus 2 divided by 1 minus cos 2z. Now by the trigonometric formula we know that cos 2z is equal to 1 minus 2 sine squared z, and so this can be rewritten as 2 sine squared z is equal to, taking this to the right, 1 minus cos 2z. So this 1 minus cos 2z in the denominator, I am going to replace it by 2 sine squared z. So therefore this will be equal to minus 2 divided by sine squared z. I mean sine squared 2, yeah, we will be having only z, because 2 sine squared z is equal to 1 minus cos 2z. So it will be equal to 2, yeah. So this 2 we will write in the front. This 2. 2 sine squared z. So this 2 and this 2 gets cancelled, which is equal to minus 1 by sine squared z. And we know that 1 by sine theta is equal to cosecant theta. So using that, this will be equal to minus cosecant square z. So therefore, we have obtained ux of z comma 0 minus uy of z comma 0 to be equal to minus cosecant square z. So we will write that. And we shall mark it as equation 4. Now we are going to make use of the next CR equation in equation 3. That is, we have this CR equation. We will make use of this in equation 3. So here what we are going to do, at the place of Vy, we are going to replace it by Ux, so that we can bring all equations in terms of U itself. Okay, so this will become uy plus ux, which can also be written as ux plus uy, because at the place of vy we are replacing it as what? Ux. So this CR equation I am going to make use of. So let us do that in this equation 3. So I will write that. So therefore substituting Vy is equal to Ux in equation 3, we get Ux plus Uy is equal to the right hand side of equation 3. It will come as it is. Now as we did before, we shall find at the point z comma 0. So Ux of z comma 0 plus Uy of z comma 0 will be equal to, so in this, wherever we have x, we have to replace it by z. Wherever we have y, we have to replace it by 0. So if we do so, we see that here we will get minus 2 sine 2z. But what about sine 0? It will become 0, because of this, which the whole term becomes 0. Therefore, ux of z comma 0 plus uy of z comma 0 will become 0 itself. And this will be marked as equation 5. So after marking this as equation 5, we are going to add equation 4 and equation 5. So that what will happen when we add this uy of, because we have a negative sign here, uy of z comma 0 plus uy of z comma 0. This minus and plus, these two terms will get cancelled and we will get 2ux of z comma 0. When we add this and this will be equal to minus cosecant squared z plus 0. So we will get minus cosecant square z only. So I will just show that. So on adding equation 4 and then equation 5, we are adding them. So these two gets cancelled and this plus this will give us twice ux of z comma 0 is equal to minus cosecant square of z. And from this what we get, ux of z comma 0 is equal to, taking this 2 to the right, it will go to the denominator. So minus 1 by 2 cosecant square z. So this will be marked as equation 6. So we shall mark this as equation 6. We shall now substitute this equation 6 in equation 5. So substituting equation 6 in equation 5. What do we get? We get, so at the place of ux of z comma 0, we will substitute minus 1 by 2 cosecant square z plus uy of z comma 0 is equal to 0. So from this we get uy of z comma 0 to be equal to, taking this to the right, it will become plus, so positive, so 1 by 2 cosecant square z, and so this will be marked as equation 7. So this is equation 7. So now finally we are going to find the analytic function f of z. So we know that f of z is what? It is equal to u plus iv. Now if we differentiate this f of z with respect to x, what we will be getting? F dash of z will be equal to ux plus I multiplied with vx. Now if we are going to find it at the point z comma 0, it will be ux of z comma 0 plus ui multiplied with vx of z comma 0. Now again, making use of the CR equation for Vx of z comma 0, what do we have? We have the CR equation here. That is Vx is equal to minus Uy. So we are going to make use of this. So we are going to replace Vx as minus Uy. So Vx as minus Uy we have to replace now. So this will be equal to Ux of z comma 0 plus minus, because of this minus, so here we will have minus I multiplied with Uy of z comma 0. Now from equation 6 and equation 7, we have Ux of z comma 0 as minus 1 by 2 cosecant squared z, and uy of z comma 0 as 1 by 2 cosecant squared z. So we shall substitute that. So this will be equal to further minus 1 by 2 cosecant square z, and then we have a minus I multiplied with uy is what? Just 1 by 2 of cosecant square of z. Now you see, we see that cosecant squared z is common in these two terms and also 1 by 2. So if we take that out, so we can in fact take minus 1 by 2 out, and here we will be having cosecant squared z. So what will be there inside the bracket? So 1 minus 1 by 2 and cosecant squared z, when we take out, this becomes 1, and then this minus becomes plus I multiplied with 1 by 2 cosecant squared z has gone out. So multiplied with 1 only. So therefore what do we get? We get minus 1 by 2 multiplied with 1 plus I multiplied with cosecant squared z. So therefore we have got, what is this actually? F dash of z. So f dash of z is equal to, I will just rewrite it, 1 plus I divided by 2 multiplied with minus cosecant square z. So this is f dash of z. We are still not done with the problem. So on integrating on both the sides with respect to z, f dash of z will yield us f of z, which is what we want to find, is equal to 1 plus I by 2 will be a constant. So it will come as it is. And what is the integration of minus cosecant squared z? It is cot z plus a constant of integration c. So the formula that we have used here is integral minus cosecant squared z, because the integral cosecant squared z is minus cot z. So minus into minus will become plus, so it will be cot z. So this is what we have done here. So integral minus cosecant squared z is cot z. So hence we have obtained the analytic function f of z to be equal to 1 plus I divided by 2 multiplied with cot z plus c. So hence we have obtained the required analytic function f of z. I hope you would have understood this problem. Thank you.